The Sci Guys presents Gay Lussac's Law.
We are the Sci Guys! Today, we will going to conduct an experiment about Gay Lussac's Law.
Gay-Lussac's law states that the temperature and pressure of an ideal gas are directly proportional as long as its volume and mass remain constant.
But who is Joseph Louis Gay-Lussac?
Joseph Louis Gay-Lussac was a French chemist and physicist. He is known mostly for his discovery that water is made of 2 parts hydrogen and 1 part oxygen, with Alexander von Humboldt for 2 laws related to gases, and for his work on alcohol-water mixtures, which led to the degrees Gay-Lussac used to measure alcoholic beverages in many countries.
Before we start this experiment, we should wear our proper gear. Today, I am wearing a goggles and a mask. Reminders, don't do this at home, especially on kids.
So let's get started! First step, we're going to put this water on the container.
For the second step, we're going to apply this food coloring on the container so that we will be able to see the color.
And for the third step, we're going to light up this candle and put it to the center of the container.
And for the last step, we're going to place this beaker on the top of the candle.
Gay-Lussac's law states that when a fixed amount or mass of an ideal gas is kept at a constant volume and in a closed system, then its temperature and pressure are directly proportional. What this means is that when a gas's temperature increases, its pressure increases, or as its temperature decreases, its pressure decreases. As we mentioned in our last episode, an ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of gases such as Gay-Lussac's law. In our experiment, our beaker is filled with gaseous air molecules. The energy from our flames transfers to the air molecules, exciting them by raising their temperature. When the air molecules in our beaker are excited, they try and spread further apart, but because our beaker won't expand like a balloon, the volume of space our air molecules can take up is limited. As they try and expand in volume, the air molecules press harder and harder against the walls of our beaker and the water at its base. This increase in air pressure under our beaker causes the water level under it to be pushed lower than the water level outside of it. The higher the temperature or the more energy the air molecules get, the more pressure will be created under our beaker. As the candle flames burn, they use some of the oxygen contained in the beaker for combustion. The products of this reaction are carbon dioxide gas and water vapor. As more and more hot carbon dioxide gases and water vapor are produced, they fill up the top of our beaker, forcing the oxygen in our beaker that the candles need to burn lower and lower until the candles are extinguished. Once the flame is extinguished, the air molecules under our beaker begin to cool off, dropping in temperature and losing their excitement. This causes the amount of pressure our air molecules are exerting on the sides of our beaker and the water at its base to drop. As the pressure drops, the air under our beaker wants to be equal to the pressure outside of our beaker. This need for balance causes a pull on the sides of the beaker and the water at its base. Because it's much easier to pull water into our beaker than it is to collapse the sides of our beaker, the water in our shallow container is pulled into our beaker, raising the water level under the beaker, equalizing its pressure.